Have you ever looked up at the sky on a sunny day and thought, there's so much energy up there? Why aren't we using it? It's a fair question. After all, the sun delivers more energy to Earth in 1 hour than the entire human population uses in a year. That's not an exaggeration in its physics. And in space, above the atmosphere, the sunlight is even more intense. No clouds, no nighttime, just a constant stream of raw, uninterrupted power. So why don't we put solar panels in space and beam that energy down to Earth? Well, funny thing is, we've actually had that idea for a long time. The concept is known as space-based solar power, and it's been around since at least the 1960s. Here's how it would work in theory. You launch giant solar panels into orbit. We're talking kilometers across, and they collect sunlight 24/7. That energy is then converted into microwave or laser beams and transmitted wirelessly to a receiver on Earth. The receiver, often called a rectenna, short for rectifying antenna, catches the beam and converts it back into usable electricity, which you can then send into the grid like power from any other source. Sounds like a dream, right? Clean energy, no fuel needed, day and night operation, and best of all, no carbon emissions. It's like turning Earth into a giant wireless charging pad powered by the sun. But here's the big catch. While the physics works, the engineering, economics, and politics are an entirely different story. Let's start with the first problem: getting stuff into space. Launching a single kilogram into orbit still costs thousands of dollars, even with reusable rockets. And a space-based solar power system isn't light. You're talking about launching hundreds, maybe thousands of tons of materials. Solar panels, support structures, power conversion systems, and precision beam technology. That could add up to billions in launch costs alone. Now, it's true that rocket prices are coming down. Companies like SpaceX, Blue Origin, and others are revolutionizing access to space. But even if you cut launch costs by 90%, it's still a massive investment, one that requires a long-term vision and, frankly, a lot of political will. By the way, if you like this content, remember to subscribe and like. Next, there's the issue of size and complexity. You can't just slap a few solar panels onto a satellite and call it a day. To generate a significant amount of power, say 1 gigawatt, which is roughly the output of a large nuclear plant, you'd need a solar array in orbit that's several square kilometers in size. That's bigger than the entire International Space Station by orders of magnitude. And we'd have to build and assemble it in orbit. That kind of mega engineering project is unprecedented. It would require not just advanced robotics and construction technology in space, but also a level of international cooperation and funding that we haven't really seen outside of space exploration or major wars. Then there's the problem of the beam itself, the part where we send energy back down to Earth. Microwaves and lasers can absolutely carry energy through space. In fact, we already use microwave transmission for things like satellites and radar. But when you're trying to beam power, not just a signal, precision becomes everything. The beam needs to be tightly focused, narrow enough to stay on target over thousands of kilometers, and safe enough that it won't fry planes, birds, or people in its path. That means choosing the right frequency, the right power level, and building safety systems that can instantly shut it off or redirect it in case anything goes wrong. Imagine a scenario where the beam drifts even slightly. It could miss the ground station and start cooking the countryside. That's an extreme case, but it's the kind of thing that regulators, engineers, and the public would have to feel very confident about. That brings us to the regulatory and political challenges. Beaming power from space isn't just a technical question, but it's a diplomatic one. Who owns the energy? Who controls the satellite? What if one country sees another space power station as a threat? And who makes the rules for where the beam can go? Right now, international space law doesn't fully cover these kinds of activities. If one nation starts deploying massive power satellites, it could raise serious geopolitical tensions, especially if others see it as a dual-use technology that could be weaponized. And speaking of geopolitics, let's not forget the potential for cybersecurity risks. A satellite that can beam energy to Earth is essentially a giant orbital laser or microwave emitter. If someone could hack into it, they might not just steal power, they could cause major damage. That means any operational system would need military-grade security and constant monitoring. So where does that leave us? It turns out we're actually making progress. NASA, the European Space Agency, China, and Japan are all exploring space-based solar power in different ways. In 2023, Caltech launched a prototype satellite to test key technologies like wireless power transmission. Japan's JAXA space agency has had working microwave transmission tests since the early 2000s. And China has announced plans to build a functioning orbital solar station by the 2030s. But these are still small steps. The truth is, we're probably at least a couple of decades away from having full-scale operational power satellites, the kind that can meaningfully contribute to the global energy grid. In the meantime, we still have a lot of work to do here on Earth. Improving terrestrial solar, building better batteries, modernizing the grid, and making energy systems smarter and more resilient. Still, the dream is alive. Space-based solar power is one of those rare ideas that's technically feasible, environmentally clean, and almost within our reach. If we can solve the engineering challenges and bring the cost down, it could become a cornerstone of future global energy systems. And when that happens, we might finally live in a world where power from the sky isn't just a metaphor. Thanks for watching. If you learned something new, give this video a thumbs up, subscribe for more science and tech explainers, and let me know in the comments. Would you want your city powered by energy beamed down from space?